So with no further ado, let's please start off with the context introduction by Lee Calcode. Thank you.
Great. Thank you, Jacob. Thank you for that introduction. Let me reintroduce myself if I could. My name is Lee Calcode. I'm with the Cloud and Virtualization Group. So in partnership with Jacob and his team, we're helping form the Docker at Cisco organization, and we're looking to form a community around a lot of the activity that's happening within Cisco and outside of Cisco around Docker. We're going to take the audience today through some training on this topic. And I've been told that the number of registrants for this topic I think breaks a record for the Learn, Hack, Share events, which is fantastic. I think that speaks to the interest that we have in Docker. There's a number of organizations, not just CVG, but other organizations within Cisco that are either have been using containerization and are looking at Docker in specific, or some that are just starting to learn this. So we do have a broad swath of people that are here, a little over 1,000. Who we do have today is Jerome Patazzoni from Docker Inc., who's going to help us help disseminate some of that knowledge. And he's got kind of a middle-of-the-road presentation that I think that people are going to understand. So for some of you on the end of the spectrum that are brand new to Docker and have just kind of heard it as a buzzword, you'll, this quote might resonate with you. And this is taken from a talk that Solomon Hykes, the founder of Docker, gave here this year. It said, "I know two things about Docker. It uses Linux containers, and the internet won't shut up about it." And that's very true. We're going to talk about why that's true. So for some of you that have been around this technology for a while, I think, especially if you're an engineer, you'll end up sort of pedantically telling people, hey, this isn't new. Containers have been here for a while between Solaris and the C groups and things that were in Linux previously. So why is this such a big buzz already now? And that's because Docker has made this technology more palatable. So some of the things we're going to talk about today are Docker specific, but some of these things have been here for a while, and Docker is just helping kind of reinforce it. So containers are fast. These are some of the reasons why you guys should be paying attention to this technology and why it is that you're looking at using it now. So when we say fast, we're comparing the containers to VMs, which isn't necessarily a fair comparison. We're going to talk about kind of why it isn't, but I think for right now, for those of you who are new to containers, it's probably worth kind of drawing that parallelism in your mind. So how fast? They take virtual machine operations, container operations, things like starting and stopping them from minutes down to milliseconds or to seconds. Jerome will give us an example of that. They are agile, so they are nimble to the extent that they're lighter weight. That we changed from talking about VMs being or containers being gigabytes in size down to megabytes in size, which means that they're much more portable. That they like VMs bring the promise of being able to move them between clouds, move them between physical hosts and virtual machines. So Docker containers can run inside of VMs. Docker containers can run inside of Docker containers, actually. We're going to talk about that. So they're these smallish in nature virtualized environments that let you, as an application developer, put in either a singular service, maybe a singular process, and containerize it into a container. Your application may be comprised of multiple containers, but that's how they become nimble. You can spread them out, you can scale them. So they're inexpensive. This is open source technology that we're talking about. This support for containerization has been in the more recent Linux kernels, so it's just out of the box there. There's a large ecosystem of support around Docker, a vibrant community. There's the Docker Hub. For those of you that might have heard, it's a public repository for the sharing of images around the world. Docker Hub is one of the SaaS offerings from Docker Inc. They also allow, not only do they allow the public to use it and share their containers with one another, but they also have private registries where enterprises can sign up to just share amongst themselves. We're going to talk about an internal Cisco Docker Hub that we're bringing shortly. Containers are cloudy. So there's a big movement here in Cisco, if you haven't heard, about escape velocity and how we're becoming more agile, both in sort of execution of agile, and we've had any number of Scrum teams that are just popping up all over our organization, but also they're cloudy in the sense that as we sort of arc into this DevOps movement and we go to deliver some of our software and our services as software as a service, that containers are a helpful way to do that. They help separate some of the responsibilities between the developers and the operations ends of DevOps. They make them easier to control. So the community that we were talking about is, here's some factoids about just how much support is out there. So there's a lot of contributors. There's some core maintainers at Docker Inc. There are thousands of Docker images that are publicly available. Docker here has recently announced 11 different language stacks. So you can go out and download those different stacks and use them in your development. Docker also, within the Docker Hub, has official sort of curated images that are available. So they'll support the use of those. And I'm sort of using the word images here kind of interchangeably with containers. And Jerome's going to get into a little bit of that and hopefully help explain the difference between how a container breaks down into an image and into layers. There are over a couple hundred meetups across different countries on Docker. So it's certainly a wave that's coming, and many of you have been paying attention to that. Some of you are already using this technology today. So certainly the Cloud and Virtualization group at Cisco, both the OpenStack at Cisco group and now our Vertical Solutions team, who is comprising up this Docker at Cisco organization, have begun to use it. So has CIS, the CSG group that's helping build out our cloud services, which is our intercloud offering, how Docker and containers can come to bear there. Our SP VSS organization is looking at how Docker or containers can be used as infrastructure, how that can help them in their build process. There is, so SDU continues to bring forward new architectures and has certainly, as recently here in collaboration with others, put out a white paper on what containers should mean to us and how we need to pay attention to them. The CSR 1000V product group has been using LXC, which is the Linux container, so not Docker, but Linux containerization within their application. And then there's NOSTG, who in collaboration with others around Cisco are helping bring forward support for containers across our network appliances. We'll have a slide on this in a minute. But here's some more specifics on how, what those different initiatives are. So some of those are initiatives to use Docker and containers inside of existing products. And some of those are new initiatives, new product engagements that are coming forth. And we'll highlight a couple of these. So we mentioned the CSR 1000V. There's the Internet of Everything, which is a real broad umbrella when we talk about that. But that's, again, where teams are looking to bring forward support for running containers on top of our operating systems. We've got some new initiatives where we do want to, bring containers into Intercloud Fabric and into Intercloud itself. And as well as on the infrastructure side of the house, our OpenStack at Cisco group is working on containerizing the OpenStack controller services to help simplify and make OpenStack easier to stand up and run. And so they're looking at contributing to some incubation projects here. They're also looking into policy and scheduling with containers, and so just a broad swath of different things that people are inside of Cisco are either already using containers to do. Again, there's the SPVSS organization that's looking at using containers as build slaves. So a bunch of different use cases here. So to help facilitate some of that, that momentum, help nurture and kind of foster the use of Docker at Cisco, we're putting up an internal Docker hub so that all of you can store and share your custom images internally and privately. And that's coming very soon. It should be available at dockerhub.cisco.com. So watch out for that. You'll see an announcement of that on our community, on our Jive community. Here's just a quick pictorial, thanks to Frank Brockner's, on how it is that those containers might be coming and their support might be coming across our network appliances. The things that are put inside of those containers, I think, is probably the big kind of a big question mark. And some of those can be internal plugins as well as external third-party applications. So lots of possibilities for different systems to come to bear inside of containers on our appliances. So again, let me kind of recap here and talk about what's next. So there's the Docker at Cisco community. There's the Jive community that all of you should go to, and you'll find this recording and the training and a bunch of other resources there. There is the internal Docker hub, this Docker registry that we're going to bring forward and let you store and share your images. Aside from this intro to Docker training, I think based on the responses and feedback that we've gotten about the training, we're very likely to bring forward a second round of training. Moreover, Jerome will hopefully tell us about some training that they have coming up at Docker Inc. in October. So again, go to the community site for details on that. And then also we've got another session that's on some related technologies that are in and around OpenStack, and sort of takes a look at how it is that applications have a full life cycle within OpenStack. So many of our teams right now, that are helping build out Cisco Cloud Services and build out Intercloud, are focused on how to run, how to stabilize and run OpenStack at scale, and how we're going to go public with that. As and when we do, people are going to consume that not only for infrastructure as a service, but also because they're looking to run applications. And how do they do that? Well, there's a number of technologies that facilitate running applications, and those applications can be in containers. So join us for another training session on these particular technologies. With this, what we're going to do is turn it over to Jerome Petazzoni of Docker Inc. He's certainly an expert on the subject. He's an evangelist at Docker. And so with that, let's give a hearty applause to Jerome and jump into his training that's going on now.
Switch to Docker. I had a lot of experience with LXC that I tried to contribute to the project. I also did some minor contributions directly to Docker code around security and networking, but the main thing I did with Docker was to try to use it for everything, including like running Docker within Docker, which is actually extremely useful for testing purposes, running network appliances like VPNs or firewalls within Docker, running virtual machines within Docker, which lets you run Docker within a VM within Docker and things like that, and even running a full desktop environment, so that the X display server and all that thing within Docker. Enough about me, and let's switch to the more interesting things. Usually we ask the questions at the end, but that time we'll do that in reverse. We will ask the questions first, and I will ask some questions. I would like to know who here has tried the online Docker tutorial? A few people. And who has actually tried the real Docker things, like on some server or maybe on a boot to Docker VM? A few people. Who has installed Docker locally, either with boot to Docker or like the real Docker on a Linux machine? And who has written a Dockerfile? Less and less people. And who has an image on a Docker hub? Nobody. Okay. So here's what I want to talk about today. So what's Docker and why it is important? Then quickly I will talk about containers. Then I will talk about the Docker ecosystem, the engine, the hub. Then I will talk about how to get started with Docker, how to deploy it, what are the first steps when using Docker. And then we will talk about some advanced concepts, specifically orchestration and networking. So what is Docker and why it matters, why we are or should be excited about Docker? The idea of Docker is to be able to deploy anything, web applications, API backends, databases, regardless of the type of database, anything that can run on Linux, should be able to run inside of containers, regardless if that Linux machine is a VM or a physical machine, whether it's a cloud or on-prem. It doesn't matter. As long as it's Linux, you can run containers on it. And the idea is to deploy reliably and consistently. So what does that mean? It means that we want to get rid of that problem of that in dev, on my machine it works fine, and then when I give my code to the ops team, if they have problems because we don't have the same libraries, we don't have the same distro, maybe I'm using Ubuntu, and in prod we have CentOS or RHEL, so we want to get rid of that problem. So we also want to deploy efficiently. So efficiently, in that case, and Lee hinted about that earlier, it's about the fact that containers are lightweight and they can achieve almost native performance. So if in a typical machine you can put, let's say, 10 VMs, you can expect to put up to 10 times more containers. So that's the kind of thing we want to do. And so some people did benchmarks about the overhead of containers, because initially when you look on the paper, like the theory says, containers should have native performance, like no overhead. So is that possible? So people did tests. So those are like network benchmarks in an HPC cluster, and on InfiniBand bandwidth and latency, there is no difference at all between native and containers. Yeah.
I'm sorry, what's the difference between LXC and Docker?
So LXC is one of the underlying technologies, and Docker initially was using LXC to start containers, and then at some point we started to use directly the kernel features of LXC without using LXC itself. LXC by itself doesn't exist in the kernel. LXC is just a set of tools to leverage on namespaces, control groups, and other features in the kernel. So in the beginning, Docker was really a kind of layer on top of LXC, and then it became, okay, let's get rid of LXC itself and go straight to the source.
So Docker is the only container technology available today?
Is Docker the only container technology available today? Not really. I would say that you can use LXC directly. There are probably a few other containerization technologies available. In my humble opinion, the reason why we mostly hear about Docker is that it's good enough so that it's not necessary to come up with something else, and it's open source, so people can use it and patch it and whatever they want. If it were like closed source, or if it were extremely bad, people would probably come up with something else, and we wouldn't be talking about Docker. And I'm not saying it's perfect, but that it's like good enough so that it doesn't make sense to completely throw it away and start over. This is a benchmark that some folks at IBM did to compare OpenStack on KVM and OpenStack on Docker. And so basically the red line is when you run on KVM, and you can see that it uses up much more memory and it takes much longer to start 15 OpenStack virtual machines versus 15 OpenStack containers.
So are you saying that the complexity of OpenStack just adds a lot more overhead?
Oh, no, sorry. What I mean is that in that case, we use OpenStack, except in one scenario, we use OpenStack and we start KVM virtual machines. In the other case, we start Docker containers, but they run the same thing, the same image, the same application, the same everything else.
So is Docker on the bare metal, or is OpenStack on the bare metal? Or
in that case, they're both on bare metal. So I have I have a set of machines, and well, in that case, I think only one. And on that machine, I try to start, if I remember well, it's just an Apache server with a simple application. And so I try to start 15 instances of that within KVM virtual machines, and then I compare to 15 instances of that within containers. And obviously, if you know about VMs and containers, there is no wonder that the containers end up using much less memory and RAM, but it was kind of useful to have those kind of difference to exactly understand how much, how big the difference was.
The delta is the KVM overhead.
Sorry?
Delta is the overhead of the KVM.
Yeah, the issue is the fact that VMs themselves have a pretty big overhead. Like an empty VM has a big overhead, while an empty container has almost no overhead. So this is like some memory benchmarks, and we can also see that there is almost no difference between native and Docker, and then a little or sometimes big drop in performance with VMs. Yeah.
Is this a real comparison? Like, meaning given that virtualization enables running different operating systems, whereas Docker primarily at this time is a Linux-based thing, right?
Is this a fair comparison? I agree. It's not completely a fair comparison in the sense that, yeah, VMs, you can run different OS, you can do different things, but at the end of the day, if you're running applications for people, they don't care at all if you're using VMs or containers on some other unknown technology. What they want is, okay, I want my 15 Apache servers up and running, and I want them fast and without using tons of machines. And that's, after all, that's the goal of PaaS and infrastructure. So that was kind of to demonstrate, okay, we know that containers are going to win, I would say, this benchmark, because there is no other way that they could lose it, but we want to see exactly by how much. Is it really a huge difference? That was the point for those people. So what exactly is Docker? The Docker platform is made of two big parts, the engine and the hub. The engine is the open source part that you can find on GitHub and is completely open, free, and everything. The hub is a collection of services to make this engine more useful. You could compare that to Git and GitHub. Git is free and open source and everything you want. GitHub is a collection of online services that make Git much more useful. So the Docker engine runs the containers themselves. And so what exactly are containers? So from a high-level approach, so if I look like functionally, it looks like a virtual machine, because I can SSH in my container, I can check the running processes with PS, I have my own network interface, I can have root access, I can install packages, so it really looks like a VM. But at the same time, if I go to my host and I check the running processes, instead of seeing like one giant process for what I would have with virtual machines, here I will see all the processes inside the containers, except that those processes will have little labels telling, oh, this process is actually running in that container. And so once a process is running in a container, it can only see the other processes of this container, and it can only have access to the resources of that container. So it's a little bit like using chroot to separate applications, but with much more isolation features. So I have a quick demo for those who have never yet seen Docker in action. Can you read fine or too small? Better? Okay, so there is a small CLI, and I can basically start like an Ubuntu container like this, and that's it. I have my Ubuntu container. And I can, if I don't like Ubuntu, I can start a Fedora container, and now I have Fedora. It looks a lot like the same thing because after all, it's a Linux system. And now I can start, let's say, a Debian one. Okay, that's the Debian container. I have a certificate and I have all that stuff. And I can also, let's say, run CentOS, and we have multiple versions of CentOS, so I could say, okay, I want to play a little bit with CentOS 6. Whoops, sorry, that's not like that, like this. And if I prefer, I can also play with CentOS 7, so that's an easy way to do quick tests. Okay, and now if I do Docker PS, I will see all those containers plus another one that I was running earlier. I will see that they are still running in the background. So that's a little bit like starting VMs, except as you could see, it was extremely fast. Let's say I want like a large number of CentOS containers for some reason, and 1, and 2, and 3, and 4, and 5, and I will apologize, I will unzoom a little bit so that when I do Docker PS, whoops, yeah.
I got a question. I could see this getting out of hand. The container IDs, can you rename those container IDs?
Yes. Actually, containers also have names. Here, I didn't give them names, so they have a name which is made of a mood and an inventor, so like Hungry Newton and Trusting Fury and so on and so forth. But I can also name them if I want. So I could do.
We can reference them by the actual name.
Absolutely. Okay. Like that would be like awesome Linux, and I would like to have Ubuntu. Okay, and now if I do Docker PS, I will have this awesome Linux here. And if I want to get rid of it, I can Docker kill awesome Linux. Don't do that. And now it's gone. So yeah, and I can give other names. I don't have to give like a mood and a name. Yeah.
So you said that there's network interface for each container,
yes.
Right? Like, is there a way to specify a kind of network interface, right? Like when the container comes up, like automatically, like.
Can I change the kind of network interface? So out of the box, no. However, there are many ways to do that, and I have a specific bit about network and extensions, but yeah, out of the box, Docker will give you simple network interfaces, but there are many ways to change that. So yeah. Okay, so that's like the basic first contact with Docker. So yeah.
What actually got spawned was the work or was it just an instance of app?
So we have, what you have is one process, which is containerized, and that process can in turn spawn more processes. So you can either decide, okay, I'm going to start just Apache or Asterisk or whatever application I want, or you can also say, I want a full-blown unit system with SSH and cron and so on and so forth. And then it looks more like a VM from a functional point of view. So at this point, we can say, okay, well, this is just like starting VMware or VirtualBox VMs, except it's much faster, it will be cheaper, that's great, we'll save tons of money, let's all get back to work. Actually, it took us 3 years to realize that containers were much more interesting than just that. For 3 years, we have been using containers just as cheaper, faster VMs, and then we realized that there was more than that. When something becomes way, way, way cheaper, things change a lot. You have groundbreaking changes because people now can think about things that were impossible before, and now they are the implies that you have lots of machines, or you could do that like one after the other, but that implies that you have lots of time. In both cases, it means you have too much money on your hands. The last situation, the last possibility is to start those 100 databases in containers, and as you could see, starting a container was fast. Of course, I was just starting a shell, but if I'm starting a container with a database, it will just take a few seconds as well. So if I have 100 tests to run, I can start 100 containers with each a copy of the database, and each will run one specific test, and then I can get rid of all of them very quickly. And the key thing is that this was already possible with Elixir, but if you want to do that with Elixir, you will have to learn how to use Elixir and all the specific things with containers. Out of the box, Elixir doesn't come with a copy and write system, so we'll have to learn how to use one. The idea of Docker is to allow you to do that even if you're a normal developer and not like a super sysadmin who has spent the last 10 years learning how to use Elixir and containers. So containers make testing, but not only testing, but many other things, much easier than it used to be. So there is the container metaphor that if you already heard about Docker, you probably have that, which likens the problem to the shipping industry. Before we had, each time you wanted to ship a different object through a different medium of transport, you had a different problem. And thanks to this big blue metal box, we managed to divide by 10 the cost of shipping worldwide, which means that before containers, when you bought something, like 1/3, like 30, 40% of the cost was just shipping. After containers, it becomes so efficient that now shipping cost is just like a few percent of the cost. So we have the same thing for software. We have all those things that we want to run on laptops, servers, cloud, VMs, whatever. So we will solve that by putting the code in Linux containers and then running those Linux containers everywhere. That's the analogy. We want to enable separation of concerns, between the developers who will put everything in the containers. Maybe they love Debian, so they will use Debian and apt, and they will install dependencies and everything in containers. The code, they will use the build process that they know and love, and they will run that container locally on the laptop, and it will work. And then they will give that container to the ops team, and the ops team is maybe running on CentOS or some other distro. It doesn't matter, because containers will make that abstraction between what's inside and what's outside. And the ops team will take care of the logging, of remote access, security policies, configuring the network, all that stuff. So a little bit more about Docker and its ecosystem. I said that there is the engine, the hub, then there is a huge community, and then there is a small but growing company. So the engine is the open source part. It's in Go, which means that it's a new language. It's scary at first, but it turns out that using Go for Docker was a great decision because, interestingly, now if you look at past projects built around Docker and even not around Docker, there is like more than half of the big past projects out there that are in Go or switching to Go. Docker works by having a service running on your machine, exposing everything through REST API. So whenever I was doing Docker this, Docker that, I was actually sending a request over an API to the service running here. It means that I could talk to a Docker daemon running on a remote machine, and it would work exactly the same way. I could do Docker this, Docker that, and instead of talking to a local machine, I could be talking to a VM on EC2 or some physical server in some data center. It would behave exactly the same way. The engine also allows to build containers using recipes, and I will demo that in a few minutes, and then to share them using registries. So registries are big libraries of Docker images. So if I make an image, I can put that to a registry, and then I can tell you, oh, you can fetch the image on the registry, and you can pull that and run it on your machine, on your servers, and it will run just fine. And last but not least, it defines a format to exchange those containers with other people.
So are the registries part of that Docker Hub you mentioned?
Are the registries part of Docker Hub? Yes. So the Docker Hub is a collection of services, including a registry, but you can also run that registry on your own. The registry itself is open source. So if you want to say, hey, I just want to run a small registry to share container images with my lab, you can do that. The Docker Hub itself has more things like user management, teams, fine-grained permissions, and automated builds, and more, and those things are not open source.
Does the Docker Hub, sorry.
Go ahead.
I was going to say, does the Docker Hub manage all these containers that we're spawning, or is there like some sort of management interface?
Does the Docker Hub manage all those containers? Not yet.
Okay.
Not yet. But
so how will you expect us to manage all these containers?
So I will tackle that in the orchestration part, but basically for now there are multiple external tools to help to manage a collection of Docker hosts.
Okay. Like what?
Well, it really depends on the size. Okay. It's a little bit like the question of how do I manage my my virtual machines. If you have a few of them, a few tools will be appropriate.
Because VMware has vSphere, right? Like
right.
What do you guys have that complement? Because you also have like the container, and then you need a management interface to it. Right. So what do you have that complements that?
That's a very elaborate answer, but basically for very small deployments, there is something called Fig that lets you manage groups of containers on a single machine. And at the other end of the spectrum, for huge deployments of like 10,000 cores, you can use Mesos, and Mesos now has a native Docker containerizer, something to run Mesos workloads, and then you can run all the suite of Mesos frameworks to run that.
As a follow-up. Mentioned Kubernetes. Kubernetes is Google's.
There is also Kubernetes, yeah.
But they don't do cluster management. They don't do single containers.
There is about like at least 15 different ways to manage large fleets of Docker machines. So it really depends on a lot of constraints. But yeah, I will talk. Yeah.
The real question is, right, like, given that there is all these tools, right, like, isn't there any effort to kind of bring in the clustering and management natively into Docker itself?
So are there some efforts to bring that natively into Docker? Yes, absolutely. What we want to do is to have more and more ways for those management tools to kind of speak the same language, so that if you say, okay, I've been using Fig locally on my little machine and it was great, and now I have to deploy on Mesos, there is a big difference between the two deployment processes, and so we want to expose like more hooks and more API endpoints to kind of make sure that it becomes easier to transition from that small scale to that large scale.
Okay, but you don't intend to do something like clustering, like what CoreOS does, right? Like in terms of that Docker to Docker.
So will Docker have native clustering? Maybe. There would definitely be some again hooks to make that easier. But we'll see. Yeah. Okay. There was a question over there.
So registry is more like a meta file for the container?
So the registry is a meta file. The registry is really like, it's a library. So the registry technically is a service sitting either on top of local storage or a cloud object store like S3 or Swift or something like that. So the registry itself,
it's like an app store.
It's a kind of app store,
if you think about it, it's really just like an app store. You're just going up there, you're just grabbing a container and you just download it, whatever you want. That's all it is. No. I'm sorry, I didn't do that.
That's fine.
That's what it is.
So, yeah, I said Docker was open source. It means that Docker itself, the engine, is really completely open source. Everything like the bugs, the feature requests, all that stuff is happening on GitHub, and anybody can contribute, and there is like something explaining you exactly how it happens for some feature to be merged into Docker. So if you want Docker to interface with your coffee machine, you can submit a pull request, and as long as you get the majority of the core maintainers to approve, the code will be merged. And the maintainers are not only Docker Inc. employees, but we have maintainers working at Google, Rackspace, Red Hat, and other smaller companies. So it's not like the project was completely controlled by Docker Inc. It's really in the hands of the community now. The Docker Hub, so as I said, there is this registry so that you can push and pull images and share them, either public images or private images. And there we followed a GitHub example, which is as long as you're dealing with public stuff, then it's free. If you want to have private things, you have to give us some money. There is an automated build system that lets you link a code repository, and each time you push some changes to that repository, it will automatically make a build of your container, and in a matter of minutes, you have an image that will be ready. And there are more features like we've hinted at, managing fleets of Docker hosts, having security advisories, and all those things. The community, it's huge. We have more than 600 contributors, and even though, to be honest, probably half of those contributors just made like a few changes, like maybe in the documentations or a typo or something like that, it still means that there are many hundreds of contributors that have made significant changes into Docker itself. And we have about 20 core maintainers, so the people that have yay or nay say when we want to merge stuff. The Docker Inc. company is only 50 people, so when you do the math, you can see that, again, most of the development happens outside of the company. There are more like, big numbers, but it doesn't really matter. Let's talk a little bit quickly about the company. I say like about 50 people, but actually it looks like next week we might already be 60. We make some revenue by support and training. We also, by delivering service to the Docker Hub, so when you want to have your private container images, you have to give us small amounts of money to do that. We also sell t-shirts and stickers because the blue whale is extremely popular, but I don't know if we're going to IPO with that business plan. Okay, let's talk a little bit about how we use Docker. First, how do I get and install Docker? If I'm on Linux, I can just install it directly with apt-get or yum or whatever my distro uses. If I hate packaging systems, I can just download the Docker binary. That's one of the upsides of Go. Go gives you one binary and it embeds everything, the libraries, the dependencies, and you can just run it and it works. You can also use, if you're not on Linux or if you want to isolate things a little bit, you can use boot to Docker. Boot to Docker is a tiny image, 25 megs. You can use that as a VM in any hypervisor you want. You can also put that on a USB stick and boot it on a real machine. You can put that on a CD to boot a server. So it's a little bit like SmartOS for those of you who heard about that. So there's boot to Docker, and on your servers, well, you just install the packages of the or the Docker binary. If you happen to use any kind of public cloud, we have images available on most of them. Well, either images are really easy provisioning instructions. We also, there are some distributions that have been built explicitly to run Docker containers, specifically CoreOS and Project Atomic. Those distros didn't exist before Docker, and they appeared just to run Docker and to run containers. So earlier I said that Docker gives you a way to write a recipe to build containers. And so those recipes are called Dockerfiles, and they're great because, to make it short, it means that as developers, you don't have to learn about Chef, Puppet, Salt, and Ansible anymore. You can use that instead. It doesn't do all the stuff that configuration management systems will do, but it will do, hopefully, the part that as developers you have to deal with. So this is a Dockerfile. It says I want to start from an Ubuntu 14.04 base image. I want to run apt-get install. I want to create an index.html file, and then I want to define default command, which in that case would be nginx. And last but not least, I say that this image, this container, will be exposing a service on port 80 because that's a web server. And then I build, and stuff happens. And then I get my container image, and that will run like that. So I have static code here. I have a browser here running that. And so what I will do is that I will, so Docker PS. So first I will kill all my containers using that little command. I will, okay, good riddance. I will zoom a little bit so that you can see what's happening. Let's edit a Docker file and, whoops, wait, I can't use a Mac. So, hi, Cisco, I'm in your container, and then Docker build -t web. So I'm just naming that image, say that's web. So it will run all the steps in the Docker file, and then I will Docker run that web container. So that's the ID of the container, and then I will check where it's running. And it's running on port 49154, okay. Right, it worked. So what happened here is that it took the basic Ubuntu image and it executed all the commands, and each time it runs a command, takes a snapshot of the result, run the next command, take a snapshot, and so on and so forth. And what it did is that you didn't see like the apt-get update, apt-get install, and all those steps because they were already executed before. And so Docker was smart enough to say, well, I already did apt-get update within Ubuntu 12.04. So instead of running that again, I will just use the resulting snapshot. Oh, and I already did apt-get install nginx on top of the image resulting from apt-get update on top of Ubuntu 14.04. So I will use that instead of executing that command. Except that when I reach that point where I do echo Cisco to create the index.html file, then I never did that before. So from that point, Docker stops to use the snapshot and it starts to really execute the command. This means that when you containerize your application, when you write a Docker file for it, you can put all the slow, long, expensive steps in the beginning and have the faster things that change a lot by the end. And then you get the advantages of something which is completely repeatable, like you can execute over and over and build and rebuild, and each time you will have something completely deterministic, like no surprise, no side effect, but at the same time, it will be fast. If you work on server deployment, you typically have that kind of script that will install the packages and get the code and build everything and run the services. And each time you change that thing, you can either run it on an existing server and it will be fast, but you won't be really starting from scratch, or you can run from scratch, but then each time you change a little something, you have to bring up a new server and wait minutes, sometimes hours for the whole thing to happen. Here you get the best of both worlds. Yeah?
Can you run this on the containers on Android as well?
Can I run those containers on Android? Not officially. Not officially.
But someone should have created that initial image, right? Like the Ubuntu image, right? Like when you start from an initial image, you add your stuff, and then you repackage to create the new image. Is that right?
So I start from an existing image. I don't really repack it. I create a new image. It's like layers on top of each other.
Right, but like the original image, right? Someone should have created the base OS, right? With this Ubuntu, right? Like you take that is the starting point, right? How does one build that one?
How do we build the base images? Right. So we build them using, in that case, in the case of Ubuntu, we use the Bootstrap, for instance, and all the recipes used to build the base images are also available publicly. And so basically, if for some policy reasons you say, okay, you have a base CentOS image, but we should not have this and this package inside, and instead we want to have this and this, then you can use the creation scripts that were used by the official teams and change them to suit your needs. Yeah. Okay. So this is a slightly more complicated Dockerfile to download the source code for CouchDB and compile it and generate a slightly more complicated configuration file.
So my question, when you specify Ubuntu 14 version 12.04, where is that image?
So when I do from something, or when I do Docker run something, if the Docker will check if I have that image locally, and if I don't, it will check in the public Docker Hub. So it will ask the Docker Hub, hey, do you have Ubuntu 12.04? And then the Docker Hub will say, yes, this is the list of layers that you should download to have that image. And then Docker will start downloading that. So just to show that, if I do like a Docker run Ubuntu 12.04 bash. Just before doing this demo, I only pulled a few images. I didn't get all of them. So here, say, well, I don't have Ubuntu 12.04, so I will start downloading that. And it gets
How do you ensure that's going out to a secure repository and getting it from the right source?
How do we make sure that this is secure?
Yeah, I mean, how are you authenticating the full?
So at this point, it's mostly SSL certificates. So we connect to index.docker.io with our certificates, and that's how it works. However, we are about to release something called provenance, where images can be signed, and then you can have policies to say, I only want to run images that have been signed by Cisco IT security. And then if it's not signed, it won't run.
Okay.
Unless you do --force, yes, I want to run that image even if I know that it's insecure and it will quickly mess up my machine.
We can still force the Docker to pull from the local registry.
Yes, you can always pull from a different registry. Actually, well, I don't have one here, but basically that would look like, that would look like a Docker pull the address of the registry, or well, actually, let's say dockerhub.cisco.com, and that's, yeah. So that would be the host, so cisco.com and port 5000 / our CentOS base, for instance, version 6.5 something. That's how it would look like. Okay.
Another question I have is when you put in the Nginx, what happens if you have to do some configuration? Do you do it within the Docker?
How would I add some configuration to that? So one example would be that situation here, where I'm doing some Python development. And so I'm not just executing commands, I'm also adding content from what we call the context. So the context is just whatever is next to my Dockerfile on the file system. When I do my Docker build, I have a Dockerfile, and next to it, I might have my source code, my, in that case, in Python, it's requirements.txt. It could be a configuration file, it could be the source code, it could be whatever I want, and I can add that into my container.
These are the steps to build the Dockerfile, right? These are the steps to build the Dockerfile, and you build that. Let's say if I have, you were giving the example of database earlier. You will build your database container like this, and then register it, and then after that you can repeatedly use it.
Right. How can you do that? Because a lot of databases have static transactions that you can't just replicate a database. There's like static files in there.
My question was the empty database of the build,
Okay.
and then your app is going to build the database.
Okay.
Yeah,
Sorry.
but I
was just
understand,
curious,
yeah.
Because if there's data in there.
How do I keep state when I, In that case, there is something called volumes. I will, I'm not even sure if it's the agenda, but basically with volumes, you can say that directory here will be living outside of the file system of the container. So I can put stuff here, and when I upgrade my container, I will keep that data. That's how it works.
So that go back to the question I would like to ask. So if I deploy Docker container with a database, and now the user already put in their data, now I deploy another version, should I deploy it as a separate container, or should I overwrite whatever
You mean like, what if I want to upgrade my database from version? So in that case, you would arrange to have all the data. So let's take like MySQL, because almost everybody knows about it, but the data will be in valid MySQL. So I will declare valid MySQL to be a volume. I will do volume/var/lib/MySQL. That means that everything in that directory will be living outside of the snapshot file system, and instead will be directly on the host. And when I roll out a new version of my container, I will kind of move that valid MySQL to the new container. Except it won't be moved; it will just be kind of plugged at the right place. And
then you update the schema.
Oh, like updating the schema, that is just like with a normal database. You just run the SQL statements to alter the structure of the database, and
So can these volumes be shared? For example, like now I have two containers. How is it synchronized, right? Like in terms of the volume itself, all containers get access to the volume.
If I have multiple containers sharing the same volume, so volumes technically are bind mounts, which means that it's not like shared folders or guest FS or something like that. It's really the code path. When a container is reading or writing or accessing files in a volume, it's almost like a symlink. Technically, it's a bind mount, but it's really like a symlink in the sense that when I open those files through my container, I follow exactly the same code path as when I open them from the machine. There is no overhead, no extra lookup, no nothing involved.
So from a app isolation perspective, right? Like we don't want apps to step on each other, right?
Right. By default, volumes are only available to one specific container, and then, well, basically it's a little bit like virtual disks that you could plug into containers if you want to. But if you start a container like that, it won't get any access to a volume of other containers. If you want to share access to a volume, you have to explicitly do that. Okay, so people often ask about integration with configuration management systems. To keep this short, the answer is yes. Docker can play nice with that. But since we don't have a lot of time, I won't give too much details. So to summarize, with Docker, I can put software in containers. Then I can run those containers anywhere. And we saw that we had recipes to automatically build those containers easily. So let's take a few questions, even though there were a few questions during the presentation, and then we'll move to orchestration and network concept.
Right.
Yes.
So how does SE Linux play into securing the actual container and going back and getting elevated privileges out of the container? Because a lot of processes, if you really wanted to, you can force yourself to get elevated privileges. So how do you prevent that?
So how do we prevent processes from breaking out of containers? So the short story is that it's difficult to be able to run anything you want within containers and still have security. That's one of the big differences with VMs. With VMs, you can do anything. You can run Windows or Solaris if you want to, and it's still secure. With containers, you have to kind of reduce the scope of what you want to do, or you have to add a lot of extra layers of security. So because one of the first things that people say is that containers are not secure. You can break out of them and then have huge security problems on your hands. And even people from Red Hat, like the SE Linux experts, tell containers not contain. So that's like bad news. What do we do? At the same time, people have been running containers for years in public paths, which means that basically anyone can go and upload their code and run it. And those people haven't had security breaches. So how did they do? It's just that you kind of reduce the scope. You say, I don't want people to go into my containers, have root access, and mess up with everything and IP table rules and all that stuff. I want people to upload code, and that code will run with a non-privileged user, and that's pretty much it. And when the security context becomes this, then it's pretty, I wouldn't say easy, but it's really doable and technically reasonable to have good security.
So the onus is on us. We have to create some sort of security baseline for the containers themselves to prevent that.
Yeah, I made a much longer talk about security. That is, the slides are available online, and the slides have a lot of information, and there might even be some videos, but the slides are good enough anyway. You don't need me talking about security, just the slides are good. Okay, so let's see if I can open the next presentation, or yes. Okay. So we'll talk about orchestration and we'll talk about networking. So for orchestration, that means I want to run more than one containers and maybe on more than one host. So the thing is that, as we said like 10 minutes, 15 minutes ago, there is more than one way to do it. There are actually dozens of ways to orchestrate containers. But basically, if we were to kind of make like big families of orchestration systems, there are systems where you describe what you want into files. So there is Pig, MySQL, and all the construction management systems where you define what you want in manifests. There are systems where you have an API and you talk to that API to say, hey, this is an app. I want 20 front ends and 5 database replicas, and so please bring that up. There are systems where you want something that looks like a path, which means that you will have, if possible, like a Git endpoint, and you will just like Git push your code to that, and that magic will happen, and your code will end up running on the servers. And then there is OpenStack, and OpenStack by itself is a whole story. So I made a kind of flowchart to help people to pick the right orchestration tool. The first question is, do you want to or do you have to use OpenStack? If yes, there are 3 different ways. So Solon first is if you want something that looks like a path, or if you want something that's really like container native. Solon is a brand new, well, not new because it has a few months behind its belt now, but it's a new OpenStack project to specifically address containers and PaaS workloads. It leverages a lot on Docker. If, however, you already have a ton of VMs, you're using maybe Nova and you have tons of VMs and you want to consolidate and be more efficient and blah, 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 then you can use the Docker Nova driver, which will let you start containers instead of VMs, but you will still be able to see that in Nova, in the Horizon dashboard and all those things.
But I thought that kind of libvirt-based Docker instantiation is kind of deprecated and Heat is the preferred mechanism.
Yeah, so the Nova driver was in Havana, I think, and then in Icehouse, it became a country package instead of being in the core. That's because, well, it's more like a political issue of instead of having one thing which is official for Nova and then contribution for Heat and then Solon, say, okay, let's make that a country driver. And also because even though the Nova driver is extremely useful for a lot of people, it's arguably not the best way to use Docker on OpenStack because it's just like trying to pretend that containers and VMs are kind of the same thing, which is completely false. So for those reasons, we try to push more like Heat, where you can have a template and then you can use container resources in a slightly better way, and Solon, which eventually should become even better. If you don't use OpenStack, lucky you can go to the next slide. And then basically the question becomes, do you want a pass? If yes, then there are half a dozen of pretty great paths for Docker. Cloud Foundry, which is, as I said earlier, switching from Ruby to Go. There is Dace, Doku, Flint, Suru, OpenShift from Red Hat. All those things are more or less based on Docker. Like Cloud Foundry is not itself directly based on Docker, and Pivotal, the company behind Cloud Foundry, says, no, we're not using Docker, we're using Warden, except that Active State is building a path called Staccato, and Staccato is Cloud Foundry, but with Docker. IBM is doing something called Bluemix, which is a path using Cloud Foundry and Docker. So all those things pretty much use Docker under the hood. There is one kind of a caveat though. While public paths, so systems like Heroku or .cloud are pretty mature in the sense that there is an army of ops and SREs behind them to make sure that everything runs. If you want to run your own path, don't imagine that you will just install that and things will be easy and life will be beautiful, because running a path requires a lot of engineers and ops to keep things running. You just shift the burden of running your apps, running your scaled database, load balancers, all that stuff, instead of being the job of the application team, it becomes the job of the PaaS team, but you're just shifting things. Now, if you really have a lot of applications, like thousands of applications, it can make sense to kind of consolidate that under one big PaaS team instead of having lots of little applications, all with their different replication mechanisms, scaling, and everything like that. If you're, yeah.
When you were .cloud, right? .cloud had this kind of mechanism that we can push an app into .cloud, right?
Right.
Isn't that part taken out as an open source, just like Docker?
Did .cloud become open source, and more generally, what's the relationship between .cloud and Docker? So .cloud is a big collection of services. There is the container engine, there is a load balancer, there is a system that takes your code and makes builds with them. There is monitoring, there are metrics, there are billing. Docker is just the container engine, so just the part that runs the containers. And initially, at first, we decided to write Docker because we wanted to replace the core. Say, okay, that engine is 4 years old. It has 5 million lines on it. We have to make something new. And we decided to rewrite it, and we called it Docker because it does containers. It was in Python. And then we started to show it around, and people liked it. And we took the decision to rewrite that in Go. It was a kind of a gamble, but at the same time, one of the ideas was if we do that in Go, first, it will be easier for people to try it. Next, people who don't like Python because they prefer Ruby or Java won't just dismiss the project saying, it's Python, I don't like that. Go is kind of more neutral standpoint. And last but not least, rewriting in Go means that we would not be able to reuse any line code of the legacy code base. And that was very important for us to make sure that we would not take shortcuts and that Docker would be able to stand alone and be useful by itself. And each time we would do an iteration and show Docker to more people, they were like, yeah, we love that and we want you to do that. And each time we would kind of steal engineers from .cloud to put them on Docker until there was only a few people left to keep the platform running. So that's the short history. Orchestration, if you don't want to pass and you have only one host, then there is something called Fig, done by a company called Orca that we acquired recently because those guys are really great. And basically the idea of Fig is that you write a small YAML file and you say, I want to have a container called web and another called DB, and those are the parameters for my containers. So you can think of that a little bit as parameters for Docker run. So when you see that, it's pretty easy once you know Docker to translate that into Docker this and Docker that. But the idea is that once you have this file, you can do Fig up, and it will start those containers, build them if necessary, do all the stuff you expect it to do, rebuild the containers if needed, and it will work. Recently, we were starting to play with Mesos, and so Mesos is complicated because you need a master, a slave, and then a framework. And we realized it was pretty easy to write a Fig YAML file, and you do Fig up, and it brings up a complete Mesos cluster up and running with the web interface and everything, without installing anything else on the machine. Problem, Fig, for now, only supports single hosts. So what if you have a few hosts? Then you have Maestro NG, which looks a lot like Fig, except you have to assign the containers to different hosts. So you have to do some manual work, but you can use multiple hosts. You can also use your configuration management system. If you use Puppet, Chef, Salt, Ansible, instead of telling them, I want Apache to run on this machine, you say, I want that container to run on this machine. So you just map to this concept. If you have like hundreds of hosts, there are a few things like Helios that has been developed by Spotify, and the idea is that you have an agent installed on each Docker machine, and that agent connects to a central master, and then you can do commands to deploy. There are not a lot of tools in that space. There is the fact that I only listed Helios is not to say use Helios, because I also intentionally mentioned like 3 empty spots to say that there are a lot of opportunity here, because right now there is a kind of a gap of tools. If you have many hosts, then basically Mesos. Mesos is great. It's production ready. It's in use on tens of thousands of cores by little startups like Twitter and Airbnb. And so, yeah, it's a good solution. Kubernetes was mentioned earlier. It's still work in progress, but if you feel like contributing, it will also be very useful. Now, let's talk quickly about service discovery. We'll go very quickly on that. There is one concept in Docker called links. So links, that's typically when you want multiple containers to talk to each other. And typically, to answer a question in the WebEx, Ziki is Zookeeper. If you have like a web frontend and a database, you want the web frontend to connect to the database. And so you will link them that way. And then once you link containers, you can connect from a container to another, either with DNS entries. So in that example here, I decided to call that link SQL. So now I can do ping SQL from my web container, or in my PHP code, I can put SQL as the host name for the database. Links currently don't work across multiple hosts, so we have something called the ambassador pattern. And the idea of the ambassador pattern is like this. I have a web container and a database container running on 2 different hosts. And so I will have, I can do that, great. I can have wiring containers or ambassadors that will be linked with my database and web container like normally. So the database container thinks that there is the web container or something connecting to it. At the same time, the web container thinks that it's linked with the database container, but actually they are both talking with an ambassador. And ambassador then communicate with each other to find the actual location, to reroute the traffic if something goes down or is moved around. And so that kind of communication can be implemented in very different ways, depending whether you're on-prem, and then you might want to use like VLANs and multicast discovery, or if you are in cloud and then those things don't work, and then you want to use some kind of high available key value store like Zookeeper or etcd and set up like redirectors with HA proxy or IP tables. So those are a few examples of implementation of ambassador patterns.
Do you have to run the ambassador on a separate device?
The ambassador typically runs on the same system, and there are interesting ways so that it can be a different container, but it can still share enough information with the other one so that it's fully transparent.
So does the ambassador have to be central to everything and up all the time?
The ambassador itself will kind of have to be up because it will be the point of contact for the remote service. It can be thought of as a kind of proxy to the real service, but it's kind of dynamic proxy. You connect to it and you say, whoa, where is the MySQL database? There, okay, I connect to that, and as the application is transparent, you're just routed to the right place.
Okay. I have a little bit more, but
okay.
So if you spoke about the link, right?
Yeah.
Is the link is it going through the networking stack, or is it like a unique domain structure?
It's actually very open in the sense that most of those implementations, the link will go through the network stack, but you could have the links connect to local hosts and then use some fast transport to the remote destination and have the traffic go out from local hosts as well. So yeah, ambassadors, I can skip that because we are almost out of time. I want to talk a little bit more about networking. And so the Docker networking model, as we said earlier, containers have their own IP address. They're connected through a virtual switch. So it's a little bit like with VMs. And Docker does the IP allocation. When you connect outside, you go through NAT or masquerading. And when you want to connect inside a container, you have to explicitly expose the TCP or UDP port for it to be available from outside. Containers can talk to each other except if you lock down the network model by disabling ITC, intercontainer communication. That's a flag that you can switch site-wide on the whole Docker process, and then the containers will be isolated except when you use links. Links, in that case, will have both a service discovery and a security feature. There are other ways to have containers communicate with each other in the tag world. There is, when you run a container, you can use docker run --net host, which means that the container will reuse the networking stack of the host. then you bypass entirely the bridge, IP tables, and all those network things, and the container will have access to the network interfaces of the host. Not great if you're doing PaaS, because someone could just upload an application to grab all the available TCP ports. Great if you want to fill up those 410 gigs link and you can't afford the overhead of the other stacks. You can also share the network stack of another container. And that kind of loops back to the question earlier about, do I have to run the ambassador on separately? The idea here is that I can tell my application, you want to connect to MySQL? Okay, connect to localhost 3306. But there is nothing on 3306 except you start an ambassador in the same network space, and the ambassador listens on 3306. It's a way to do service discovery without bothering about host names, IP addresses, anything like that. You just connect to localhost on some port number, and on localhost on that port number, you have that magic proxy that will route the traffic to the right destination. There are a few SDN frameworks out there. Weave is one of them. Pipework is kind of another one. The thing is that most of those frameworks have downsides in the sense that they require you to install something on the Docker host. So if you just have API access, it doesn't work so well. So there is, again, like a big opportunity in this spot to have an SDN framework for Docker that wouldn't require installation of extra stuff on the host, that would play nice with the API and would still allow like plenty of interesting network topologies. That's all I got. Thanks. Cool.
Fantastic. That was great. There's much that was left unsaid to think about Docker and some of its capabilities. I know many of you had some questions on orchestration systems. How do you control containers as they sprawl and within hosts, between clouds, that type of thing. There's much unsaid, I think, about Jerome and actually some of his networking history. I think he was being humble again about not only some of his contributions to Docker, but Pipeworks was just mentioned. So that's a project of his. There's other kind of Weave and other networking projects out there about how do systems get up, talk to each other, how do they maintain, how do they stay stable. So with that, it's clear that we've got a number of questions that we're essentially out of time for. We did get a number of them in here in the room. I do want to thank the panelists that we have. They've been taking on quite a few. We're going to get those Q&A published. We're going to hopefully get Jerome to give us his presentation so we can share that with you guys. It's clear that we need another round of this. We may even get a 2-day course here at Cisco. So Jacob who I'm standing in front of, will facilitate that if we can get that going. There is training that is available from Docker Inc. There's coming up here in October. We'll get that information out. There's a number of other topics that were just touched on. So I will say that not only will we have additional training on Docker, but we'll also have some on those related OpenStack topics. Solem is one of the ones that Jerome mentioned that's sort of near and dear to our hearts. We'll come through and show you some of the things that have been done with Puppet as well, kind of how containers and other configuration management systems actually do live together, that one doesn't engulf the other. So lots more to come, and stay tuned. Jacob will be in contact, I think, with you guys in the community about where to go for the information and recording. Again, thank you, Jerome.
Thank you.